So, introduction. In this lab, we use Tracker and GlowScript to calculate a loop to display or record the motion data of an object in oscillation. We then compared these statistics to conclude whether or not the system follows the energy principle. Relevant formulas is Newton's second law, where force equals mass times acceleration. The energy principle, where the total energy is equal to Q, which is all the work done, or sorry, heat plus all the work done on the system. And then update formulas. So the position update formula in the X and the position update or velocity update formula and the other velocity update formula. Reasoning, as always, the graphs are the easiest way to visualize and express coordinate data, and GlowScript and Tracker are the most convenient sources of obtaining data in this situation. Our tracker data is as follows. GlowScript, our initial bonds, our mass is 0.402, and our initial position is 0.0697. So I did this a little bit differently. I had the origin set above, not right at the mass. So I had it set right above the mass. So our GlowScript model, as you can tell, we calculated spring force on mass by the spring. We calculate the net force of the gravity plus the spring force, and then based on that, we can use that to find our ball velocity or the mass's velocity where the change in time that we have, and also we can find its position. And then we use the update spring. So we use that to find the new spring force and so on and so forth. And it kind of goes on a loop like this. Then we use that to calculate the energy change. Tracker for this application, we simply plotted the location and coordinates of the object for each time instance in its motion until we had plotted enough coordinates for Tracker to generate a decent graph. GlowScript, we plugged it in to calculate the values, which allowed GlowScript to loop until we found equal adequate when graph was generated. Then we compared from there. As you can tell, these are our GlowScripts, so they look pretty decent. I mean, they match up pretty well with how the experiment went. The experiment was a little bit different because I probably had human error based on tracking mass. Error possibilities are obviously human error is ubiquitous. Could have had different measurements and then input and calculation could have been wrong. Competition model assumes ideal conditions, so no interference from surroundings, which is not always the case in a real model. Discussion, the energy principle is satisfied since no external force is acting upon the system. The change in energy must be zero, as shown by the graph. Comparing periods, calculating the periods for x and y directions, it generates slightly different values, meaning whichever you choose will change the spring constant in the graphs. And that is everything for today. Thank you very much.